AI coding assistants are absolutely everywhere right now, and the race is on. I mean, it feels like every single week there's a new model from OpenAI, Anthropic, or Google, and every single one of them is bragging about a higher score on the big performance benchmarks. But what if those scores are only telling us like half the story?
What if that same AI that's helping you code faster is also, quietly sneaking in security flaws, really complex bugs, and just a mountain of technical debt that you're going to have to clean up later? Well, it turns out that's exactly what might be happening.
Okay, so let's really get into this. The whole way we've been evaluating these tools, it's kind of broken. We're so focused on these performance benchmarks, which are basically just how well an AI can solve a coding puzzle, that we've accidentally created models that are geniuses at passing tests, but not necessarily at writing good, clean, professional-grade code.
And this chart just lays the trade-off out perfectly. So along the bottom, you've got the benchmark score, right? Functional performance. On the side, you've got cognitive complexity. That's basically how hard the code is to understand. And the size of the bubble, that's how much code it writes. You see the pattern? The top performers, your GPT-5s and Claude Sonnet 4s, they're way up there in the top right. They're getting those high scores by writing a ton of incredibly complicated code.
But before we start digging into the unique styles of each model, we've got to understand something that's, well, it's crucial. Underneath it all, every single one of these AIs, from the little open source models all the way up to the latest and greatest from the big labs, they're all built on the same foundation, a foundation of shared strengths and, more importantly, shared weaknesses.
And, to be fair, they are great at some things. Generating code that actually runs, solving those tricky algorithms, for sure, that's why we all love them. But the real story is on the right side of this slide. They all struggle with the same fundamental blind spots. They have little to no security awareness, they lack basic engineering discipline, and they have this built-in bias towards writing messy, hard-to-maintain code.
And when we talk about security, we're not talking about minor little issues here. For most of these models, the majority of vulnerabilities they introduce are rated blocker. That is the highest severity you can get. They keep making classic mistakes like path traversal and injection because they're just mindlessly repeating bad patterns they saw in their training data. They literally can't see the bigger picture they'd need to prevent these kinds of attacks.
So if the benchmark scores are misleading and they all have the same basic flaws, how in the world are we supposed to tell them apart? Well, this brings us to a much better way of thinking about them, as having distinct coding personalities.
Now, this isn't just some cute metaphor. We can actually measure this stuff. A coding personality is basically a profile we build from real data on a model's style. How chatty is it with its code? How complex are its solutions? Does it even bother to write comments? These are the traits that really define how an AI thinks and the kind of code it's going to give you.
All right, let's meet our first archetype. This is Claude Sonnet 4, and we're calling it the senior architect. It gets the top performance scores by writing really ambitious, wordy, and super complex code. Just like a senior engineer who's designing a massive enterprise-level system.
And then, on the complete opposite end of the spectrum, you have the rapid prototyper, which is OpenCoder 8B. Think of this one as that brilliant but really messy junior developer, laser-focused on one thing and one thing only, getting something, anything, working, and getting it done now.
The rapid prototyper is the AI you want at a hackathon. It writes the absolute least amount of code of any model to get a solution up and running. But, and this is a huge but, the source report calls it a technical debt machine. Why? Because its code has the highest density of bugs and issues, and it has this terrible habit of just leaving dead, unused, and redundant code all over the place. It's fast, yeah, but boy does it make a mess.
So what about the jack-of-all-trades GPT-4o? We're calling this one the efficient generalist. It's a pretty solid middle-of-the-road choice. Performance is good, complexity is moderate, but its personality has a very specific quirk. It fumbles the details. A staggering 48%, almost half, of all its bugs are simple control flow mistakes. It gets the big idea, but it constantly trips over the simple logical steps to get there.
Okay, so all of this is building up to what might be the most counterintuitive discovery in this whole analysis. It's something the report calls the upgrade paradox, and it really challenges a core assumption we all have about new tech.
I mean, when a company releases a newer, more capable version of a model, we all just assume it's an improvement across the board. It should be safer, cleaner, more reliable. That just makes sense, right?
Well, the data tells a very different story. Sure, the benchmark pass rates go up, the newer models are smarter on paper, but look at the kind of bugs they're making.
When Claude was upgraded from 3.7 to Sonnet 4, its rate of creating these incredibly difficult concurrency bugs jumped from just over 1% to nearly 10%. And GPT-5? A full 20% of its bugs are in this super dangerous category. They're trading in common, easy-to-spot flaws for much more subtle, systematic ones that are a nightmare to debug.
So, what are we supposed to do with all of this? What's the new rulebook for coding in a world where AI is everywhere? Well, it really just boils down to a new mandate.
This quote from the report just says it all, perfectly. We're in a whole new era where more capable doesn't mean less risky. It means the risk has changed. It's shifted away from obvious problems to these hidden complex challenges that are way, way harder to find. At the end of the day, it really just comes down to this timeless engineering principle, and it's more critical now than it has ever been. We can trust these tools to help us work faster, to accelerate what we do, but we absolutely must have rigorous systems in place to verify everything they produce. We are still the ones on the hook for the quality and security of the final code.
So the next time you're picking out a coding assistant, don't just ask which one has the highest score on a benchmark. Ask yourself this: what is its personality? Is it an ambitious architect, a messy prototyper, or a clumsy generalist? Because knowing that is going to tell you way more about the code it's about to write for you.